Alright, welcome back. On this video, we'll step away from RNGs and get into another topic, and that is UI. Now, what is UI? Just like RNGs, UI is an acronym, and it stands for User Interface. User interfaces are collections of visual and interactive elements that communicate information to the player and allow the player to interact with the game system. User interfaces usually include stuff like a HUD, another acronym that stands for Heads-Up Display. A HUD is an in-game overlay, like a health bar, ammo counters, mini-map, objective markers, as such. However, user interfaces are not limited by that. UIs also include main menus, pause menus, settings, save load menus. With that being said, I want to start creating an UI for our game, for our project. On this video, we'll create a score system, allowing our player to keep up a score. Now, here's the basic logic. Our score will increase as long as we are avoiding the obstacles. Our score will be equal to the time spent avoiding the obstacles and staying alive. So 1 second of playtime will equal to 1 score. Okay, let's go to our Unity editor and start working. First, we're gonna handle the visual part. We're gonna create another game object into our hierarchy, but this time it's not a 3D game object. No, instead, let's right-click, go to UI, and then we'll click TextMeshPro. As soon as we do that, we are greeted by this pop-up. We're gonna click Import TMP Essentials. TMP stands for TextMeshPro. We're gonna do just that. We don't need the examples or extras, so we will now click this pop-up. Okay, now we have a test game object. You can see that with our text came another object. The other object being our canvas. Now, our canvas is a spatial game object that contains all of the UI elements in our scene, whether it be buttons, text, sliders, stuff like that. Now, if we zoom out just a little bit, we can see that our canvas looks very big compared to our scene. The canvas looks huge in the scene because it's drawn in screen pixels, not word units like the rest of our objects. So it's sized to match our whole screen rather than our game world. The canvas is like a giant movie screen sitting over our tiny game world. It looks huge because it's made to fit our whole screen, not our scene's layer, not our scene's scale. Now, I want to play with our text objects, starting with repositioning it. You can see that right now in our game view, our text object is right here. It's not fully in the frame. We'll put it in frame and then move it to right here. So, selecting the text object in the hierarchy, let's just move it. Now we're gonna move it upwards. Okay, that looks fine. Now we don't need to make any adjustments to our text object's text input. It's probably obvious, but the text input holds what we want to show as the text. So if I have to give an example, if I change our text input from new text to test, and you can see that both in our game view and our scene view, the text changed. But we'll change our text input in the code in our script. So let's take this change back. There we go. Now let's head back to our script. Right now in our project we have two scripts. an obstacle behavior, and a player behavior. We won't do any of today's we won't do any of today's coding in our player behavior or our obstacle behavior. Instead, we'll create a third script just for the UI. Let's make that right now. Creating a mono behavior script. We'll call it HUD, or maybe we can do HUD manager. Okay, now we need to assign this script to somewhere for it to work. I'll try assigning our object directly to our script. Directly to our canvas. I hope that won't give us any problems. There we go. Our canvas now has the HUD manager script. Now let's open up our script and get to coding. First, we need to import a library, a built-in package to our script. We're going to work with TextMeshPro, so we need TextMeshPro's library, we'll do that by writing using TMPro. We are not going to work with the canvas. Our canvas just holds our script. Instead, we'll work with what's inside the canvas, the text game object. So we want to introduce set object to our script. We'll do that by creating a variable in our script. We'll assign to this variable in the Unity editor, specifically in our inspector window, so we'll make it a public variable. Then we need to choose a variable type. Our text object is a game object, and in cases like this, our variable type is usually game object. But this is a special case. Instead, the correct option is TextMeshPro UGUI, which is used for when working with canvas elements, which is what our text object is. It's a canvas element. Now let's call it something like text object, save it, and let's assign it in our Unity editor. Back in our editor, we can see that our HUD manager script now has the text object variable visible because we set it to public. We want our text object to be this text object. So we'll direct this directly to here and assign it. Okay, but now we need a second variable. Remember what I said. Let me give a reminder. We want to make it so 1 second of playtime equals to 1 score. Cool. This means that we need a variable that can keep track of the seconds we play the game without dying. The obvious answer for this may be using an int, but this time we'll use a float. You'll see why in a few moments. Going back to our Visual Studio, let's set up our second variable. We'll make it private. We don't need it to be public. We'll make it float. Then let's call it playtime counter. Okay, 1 second of playtime equals to 1 score point. We will break down how this works in a moment, but for now, just following along with me. Go to the update method and write playtime behavior equals to time.deltaTime. Actually, not equals to. Instead, we'll make a little adjustment by adding a plus right here. So in the previous videos, I mentioned that time.deltaTime is the amount of time that passes between one frame and the next. What we are doing here is adding that tiny slice of time into our playtime counter every frame. For example, let's pretend that on our PC, our time.deltaTime is 0.24. On the first frame, our counter will be just that, 0.24. But then on the next frame, it will be 0.48. And then on the third frame, it will be 0.72. By the fifth frame, it will be 1.20. That means roughly 1 second has passed. And we can use that to turn real playtime into score. Now, the next step is to put this value into our score text. So we'll write text object dot text equals to or playtime counter converted to int, and then at the end to string. But now it is giving an error. I didn't expect that. Maybe it's about the parentheses. I think these two parentheses are not needed, so let's try removing them. Nope. Oh, right, sorry. We'll put a second parenthesis right here, and then we'll close it right here. And there we go. Now let me explain what we did right here. First, our playtime counter is a float variable. So we remove the decimal numbers from our counter by converting it to an int variable. Then we convert it to a string variable before assigning to our text object text. We wrote text object dot text instead of text object because we are not making an edit store text object, not directly. Instead, we are making an edit store text object component, with that component being the text input. Okay, I think that's it. Now all that's left is to save and hope that it works. Let's save and go back to our editor. Okay, it's 0 now. Okay, you can see that it works. It's timing the seconds and it's putting set counter to our score text. But I want to make an adjustment. Right now, our score text is showing only the numbers. I want to make it so it says score equals to 10, something like that. So I want it to show that it's a score. We'll do that by going back to our Visual Studio and let's add our text string value. Let's write score, and then there we go. This right here is a string variable, and this right here is also a string variable. So what we are doing is combining both of these together before assigning to our text object. Let's save it and see it in the works. There.